Hi, this is DSC424 final project presentation. I'm Serena.
This is Yu Jao.
So our project flags a human resource problem. Attrition is defined as both the volunteer and the involuntary reduction of the company's workforce. In a company, those employees who volunteer resign may have different reasons. Some are due to the company's overall working atmosphere. Some are because they are personal reasons. To find the common facts that affect those workers who leave is the essential step for HR department to anticipate employees with potential reasons. So for this project, the goals are first, uncover the factor that leads to IBM employee attrition. Second, we predict if an employee is likely to quit. So we mainly use the software R to achieve these goals. During the progress, first we create the basic regression model and use the forward selection and the backward elimination to check the variable select. Second, check the overfitting problem, and we use the lasso to choose the best lambda. Consequentially, handle the regression models overfitting problem. Thirdly, we have checked the multicollinearity problem based on the model by analyzing the high correlation among the independent variables, apply the principal components analyze and the linear discriminates analyze to achieve dimensionality reduction. Use the ordinal analyze to analyze those ordinal variables. Finally, make a logistic regression model and using receiver operating characteristic to predict on the test datasets. So for the data background, the dataset that we used was published by the Human Resource Department of IBM. The download link is from the Kaggle website. Before we did the data cleaning, the data contains 37 variables and about 23,000 rows in total. So after we decide to use the dataset for this project, we determined to delete some redundant variables, including daily rates, employee counts, application ID, over 18, and the standard hours. By continue finish data cleaning, we convert some variables from the categorical and the numerical type. After this step, the dataset has 23 variables, including 11 categorical and 12 numerical variables. These two data type describe each employee's background and the characteristic and labeled whether they are still in the company or whether they are have left. Also, we delete those N8 row, which is about 230 objects. So before analyze these data sets, we separate the data set into two parts. 18% of the data counts for training data sets and the rest are the test data set. So now I will pass to Yueting to talk about the first part of regression.
Hello. In the next section, I'm gonna majorly using the PCA to analyze our dataset. First of all, I use the lasso regression to perform the feature selection. In order to maximum the performance of feature selection, I chose a lambda as very low, almost around 0. So we can see the result from the left side picture. We got a really good result because the total 25 numerical variables are being reduced to total 14. Further on, I would love to try some other method to continuing with the feature selection. So I chose both the two forward and backward stepwise selection. Luckily and unluckily, we receive exactly the same result from Lasso. So this is also a good news to support the Lasso result. So from now on, my data set is exact like the 14 variables. I'm gonna start a PCA. For here, I use the scatter plot and the correlation values to overall checking all those 14 variables. We can see the scatter plot. They're a little messy because we have extremely large data set, but all the histogram are very clear. We can see some are normalized, some are more even, some are left or right kiwi, and the correlation values, some are higher, some are lower. Might include some overlapping, but After perform the PCA, we can see all the components are pretty perfectly normal distributed, and all the distribution of the scatter plot are perfectly and with all zero correlations. It is strongly good at handling all those overlapping problem. So let's go through the detailed result of PCA. In my model, the result conclude total 14 components. Here is the problem that how many components I should choose for my future analysis. We can see the first component contain about 10% of the total variance. The second contain about 10 and 7, 7, 7. So we also see exactly the same result from the ski plot. Everything above the line here is recommended. So it's 1, 2, 3, 4, 5, 6, maybe 7. But here we can see the same thing here. The first two are dropped significantly and then more evenly. Based on the analysis complications, I choose something in the middle, which I decide to choose only 4 components in my future analysis. Here is a biplot of the PCA result. The biplot is a very important part of a PCA analysis. We can see here, there's about 3 small groups, one located in the center, one on the right, one on the bottom. Let's go through the bottom one. It's environment satisfaction and hourly rate. We can see this small group of variables is far from the center, which is good. The far away from the center means it strongly contributes to our predicting, and also those two are very close located, which means these two are strongly correlated with each other. And also there's a small group here. They are years in the current role, job level, and age. Also the angle, they are pointing to different direction. So we can see the scale here. The Y direction is indicates the component 2. The X direction is indicates to component 1. So we will see here something more detailed. As I mentioned, age, we can see it's pretty large. Job level, pretty large. Sorry. Year in the current role, pretty large. Exactly match this small group. Go far away from component 1, which means these 3 variables is strongly contributed to component 1. So this is basically the relationship or the formula between all these variables and with PC1, same thing, variables with PC2, PC3, PC4. So let's go further. Because our goal is to predict and to find which component or which factor is more strongly contribute to our target variable attrition. Based on this, I made a model with PC components and make the attrition as the response variable. So we have the result here. Very clearly, we can see PC1 is positive correlated with attrition and PC2 negative and so on. So we can go back to the correlation with all these variables. We can easily come to the conclusion or some general summary like for PC1, we can say the employee who at younger age, who work in a lower level of job level, and who also work in the current role for less years, are potential to leave, means it strongly contributes to attrition. In PC2, there are only 2 of them are strongly contributed. It's like hourly rate and job involvement. So we will get the result from here. The employee who value their environment satisfaction lower, plus they have a lower hourly rate, they are kind of easily to leave. So I can do all the same thing to components 3 and 4. So this is the result from my model, but how much is accuracy of the model? Is that enough for the prediction? So I created the misclassification calculation here, and also the prediction accuracy. They're almost the same thing, just from different angle. We can see here the misclassification error from training data set is around 15–16%. And for testing data set is almost the same, 16%. So in other words, my model's accuracy level is above 83%. I think it's pretty much good to predict the future employees, their how much they could contribute to the attrition. So next part, Serena gonna continue with it.
So after getting applied PCA on our datasets, I used another dimension reduction technology, LDA, to do it. Look at the output. It's clearly to see current employee is about 84%, and the rest are volunteer resignation. The group means are the main in each group of the independent variables. Those are the what LDA are trying to separate those means. Then we got the actual computation, the coefficient of linear discriminate. Since I separate two classes, volunteer resignation and the current employee, is accomplished by one component. There is only one LD coefficient of linear discriminates, and the formula would be the negative 0.066 times age plus 0.035 times distance from home, and so forth. Further, since we only have one component, we didn't get a proportion of trace from the loadings, which is the components contribute. We can see the linear discriminant has the mostly hourly rates on the negative side. On positive side, we got 0.4 times job involvement, 0.4 times stock option level, and 0.6 times the percentage salary hike. So after I applying it on the training datasets and look at the histogram, there is actually a huge overlap with quite a bit more confusion between these two groups. And plot the transform data, we can see the classification. Here is very, very small separation, but most of the categories are overlapping. Like we got from the histogram, calculating the confusion matrix, we got a not perfect fit here. To test overfitting, we reserved a test set and a training set. So we got the sample of 18% and the rest for test sets. After I build the model on training sets, look at the output. We got a similar output from the parameters here, and the loadings. Things are looking pretty stable here. Also for the histogram, very similar. Compare them to the previous one. We did little better, but we really cannot still separate them. That's because this attrition dataset is not a very separable dataset. Here, there are lots of variables are in the similar distance with similar size and with similar magnitudes, and the size of the objects are huge. In n-dimensional space, these classes separate themselves are not very well. We also did a logistic regression. First, we used the general linear model function with a binomial family. As you can see from the results, we got almost every variables are significant. After I predict on the test sets, and that's the table for the confusion matrix, we got 716 false negatives and 1 false positives. The accuracy is basically coming out with to the 84.6%. Then we look at the receiver operating characteristic, and it's curved, which is actually pretty good right here. The area under the curve is 0.71. So now I will pass to Yueting to make a conclusion.
Now let's come to the conclusion. Based on our analysis, we can easily come to some summary part from our analysis and based on our data set. The first one, the employees who are at a younger age and also working for the lower job level and work less years in the current role shows a higher potential to leave. Employee who value their environment satisfaction with lower score and also have a lower hourly rate, which is strongly contributes to attrition too. Employees who live farther away from work and who work less year in the current company, they are easily to choose to leave. The variables of job involvement, stock option level, percent salary hike, hourly rate are obviously strongly contributes to our target value, which is attrition. Thank you for watching.